So I find it easiest to make the graph first, and then we'll talk about it. So we're going to make our first economic graph here. And in economics, we are constantly in the first quadrant of the Cartesian coordinate plane, right? We don't need any of the negative stuff here. We don't need any of the negative stuff here. So for almost all of economics, you're just going to be using that top left quadrant of the Cartesian coordinate plane. So almost always you are going to be just drawing a giant L. Oh, and then I have a thing where I can, if I hold it, maybe, it'll give me a straight line since I can't draw straight lines. Yeah, look at that. Beautiful. Okay. So these are axes that are going off into infinity. We're going to put burgers on the y-axis here, and we are going to put bus tickets on the x-axis. And we start out with the situation where we buy 5 hamburgers and 0 bus tickets. That's one of the possibilities for the amount of money that we have and the amount of money that burgers and bus tickets cost. We also find that if we wanted to sacrifice one of those hamburgers and have 4 hamburgers, well, then because of the cost of hamburgers, that means that we could have 1, 2, 3, 4 bus tickets. So at this point, 4, 4 is our next choice that the person could make. So they could either get 0 bus tickets, 5 burgers, or they could get 4 bus tickets and 4 burgers, right? I'm just doing the X, Y coordinate pairs on there for us all. Am I losing anybody? Are we all good? Okay. And so this continues, right, along a straight line. Up until the point where we can buy 20 bus tickets or 0 burgers. So we have our extremes, right? And then we have a certain number of points in between the extremes. Different combinations that we can buy with our current income or our current budget. And so let's go ahead and write that out. Our budget is $10. Burgers cost $2. And bus tickets cost 50 cents. So this budget constraint that we have here, right, this is telling us all the different possible combinations that somebody can afford, given the price of the goods and given that they're spending everything, right? So there's no saving in these models. It's a use it or lose it kind of situation. If you don't spend all $10, it's going to go away. So you use everything, which creates what we call the boundary of the opportunity set. Just like the boundary of a map, right? We call it the opportunity set because these are all different combinations that you could choose. The opportunity set is all the different combinations. So this is part of the opportunity set right here. This is part of the opportunity set. You know, this one down here is also part of the opportunity set, right? So consumers have to choose what they need and want given the limited amount of resources that they have, right? And what we find pretty easily here is that giving up 1 burger has an opportunity cost, or sorry, giving up 1 burger gives you 4 tickets, right? So that the other way that we could say this is the opportunity cost of a burger is 4 bus tickets. Does that make sense to everyone? Because bus tickets are a fourth the cost of a burger. Burgers are $2, bus tickets are 50 cents. 50 cents times 4 gives us $2. So questions on the notion of a budget constraint and also just the notion of an opportunity cost, right? An opportunity cost is what one must give up to obtain what you desire. So it's the value of just the next best alternative. So we do have to put this in our notes here. Op cost. It's the value of just the next best alternative. So for instance, you know, the opportunity cost for being in class today might be working and gaining, you know, and getting $15 an hour, right? It might be sleeping. It might be playing a video game. It might be, like, let's say that you had 2 different opportunities that you could do if you didn't come to this class, right? You could go work at this one place for $15 an hour, or you could work at this other place for, you know, $10 an hour, right? One of the mistakes that students make all the time is they say, well, the opportunity cost is then $25 because that's the amount that they, no. That's the value of all of the alternatives together. We're just talking about the one best alternative. So if you could go back in time and choose to do something else, what would it be? And so the opportunity cost for that example I just gave would just be the $15 because that's the best alternative when we're looking at, you know, more money is good, less money is bad kind of situation. Now, a lot of those things I talked about don't have monetary values assigned to it, right? Like, how much do you value sleeping? How much do you value playing video games, right? It's very difficult for us to put numbers on that kind of stuff. And that is one of the core issues of economics is how do we translate things that are non-pecuniary, that don't have any kind of monetary value to it, into a setup so that we can compare apples to apples and not apples to oranges. So real quick, let's just do a generic budget constraint. There's a couple of zones I want to point out to you all. So the classic opportunity costs situation is guns and butter. Kicking it old school. And so we've got the boundary here. We've got some points on it. So we have some definitions to talk about here. So the boundary of the production possibility frontier is related to the amount of capital, the amount of labor, and the technology that you have. So when we graph a budget line or something like this, right? Okay, so sorry, I jumped forward. So this is a budget line, which is talking about if you only had so much money, what could you buy? Now I'm jumping towards what's called a production possibility frontier. So this is how much you could produce. So we kind of talked about a micro problem before with the budget constraints and stuff like that, right? And now we're talking about more of a macro problem, right? As a society, if we're choosing to produce things, what is feasible, what's not feasible, what's efficient, what's not efficient. And so when we have points that are outside of the boundary, these points are not feasible. We just can't get there without any kind of growth in technology, growth in capital, or growth in labor. The two that we have that are on the actual boundary, these are going to be feasible and efficient. If you're a little unclear about what efficient means, it just means that we're using all of the resources, right? We're not leaving any money on the table. Compared to this point, C, which is going to be feasible but inefficient. Questions on this notion of feasibility and inefficiency? We're gonna define efficiency in greater detail towards the end of this chapter. So right now, you just need to know that if they're on the line, they're efficient because they're using all the resources. If they're below the line, they're inefficient because they are not using all the resources. There might be people that are not properly trained. You might have some buildings and capital that are just, they don't have any people in it, right? They're sitting empty. So how do I make this higher? Can I make it higher? Probably not. Okay. All right. Any questions on budget lines and production possibility frontiers?